Hi all, welcome to lesson 2. Today's topic is simplifying exponential expressions. So I want you to pause the video, try the do now, and then you can check out my answer. Okay, so the question is asking us to simplify this expression and then find two representations for the answer. So I'm going to start by simplifying the numerator. I'm going to distribute my x and I'm left with 12x to the third minus 2x. I'm going to keep the negative out and I'm going to multiply these two quantities before I distribute the negative. So I'm left with 4x to the third plus 4x squared plus 7x plus 7 all over x squared, right? I'm going to distribute the negative and also combine the like terms. So what am I left with? I'm left with 8x to the third minus 4x squared minus 9x minus 7 all over x squared. So that's my first representation. Or I can divide each term by x squared and I'll be left with 8x minus 4 minus 9x to the negative 1 minus 7x to the negative 2. And these are two representations of the same question. Okay, so I am gonna ask you to again pause the video and write out whatever you know about these rules of exponents. You should already know about all of them, and then watch the video. Okay, so the first rule, if you have multiplication, so in multiplication when the bases are same, what do? You add the exponents, so it'll be y to the 12th, right? So the rule is add exponents, right? So the second one, in division, what do? If your bases are same, you're going to subtract the exponents. So what happens? You're left with x to the 13 minus 4 is 9 and 6 minus negative 2 is 8. So y to the 8. So what do? You're going to write subtract exponents, right? Power rule, power raised to a power, you multiply them. So this would be, I'm just going to change the color, x to the 12th. So my rule is multiply exponents, right? So the next one is what? Anything raised to a 0 power is always 1. So let's write that down. Any base with an exponent of 0 is equal to 1, right? So negative exponents, I call them like elevators. If you have a negative exponent in the numerator, it will come down in the denominator and become positive. So this would be 1 over x to the 7th, right? And here I have a negative in the denominator, so it's going to move up to the numerator. It will be 2y to the 4th. So basically, can I say flip the base? Okay, so the next one is a combination of, I would say, multiplication and raising a power to power, which is the product rule and the power rule. Basically, I wrote the rule here: raise coefficient to the exponent and then multiply the exponents. So my exponent here is 5 and I'm going to raise it to everything. So it will be negative 2 to the 5th is negative 32, x to the 3rd to the 5th is x to the 15th, and y to the 1st to the 5th is y to the 5th. So that's what it is. Rational exponents. Anytime you want to get rid of the radical and want to write it as a rational exponent, what you do is you write it as power. The power goes in the numerator and your root is the denominator. So in this example, 2 is your base, 3 is your power, so that'll be your numerator, and 4 is in the index of your radical. So that's what it is. Okay, so these were your rules, and now for the rest of the packet you may end up using one or more laws of exponents to simplify those expressions. Try those on your own, and then you can check the answers with my answer key.